Okay, friends, I'm having second thoughts about Max's dice experiment at this moment. I definitely want to use it because he generated some really cool data, but not at this moment. What I want to do is actually take a look back at the dice that I rolled. Now, keeping track of what I did before, I rolled 11 dice. I'm not sure why I stopped at 11. But I wanted to do that experiment again without, quote unquote, doing that experiment again. So what we're going to look at here is what's called a Monte Carlo simulation, which is a fancy phrase for we're going to let a computer simulate the experiment that I just did, and we're going to let it do it a lot more times. So what you see right here in front of you is an Excel spreadsheet that has 11 quote-unquote dice, okay? Every time I press the F9 button on my keyboard, I get 11 fresh die rolls. 11 fresh die rolls. Every time I press the F9 button, the dice are quote-unquote rolled again. Now, in case you're wondering how this craziness is happening, over here in column A, I want to show you, I've got some numbers hidden over here. And I want you to take a look at this as a fun command, the rand between command in Excel. You might need this at some point in your careers. Rand between generates a pseudo-random number between 1 and 6 inclusive. So 1, 2, 3, 4, 5, or 6. And every time you press F9, it re-randomizes that number and comes up with a new one. So what you're seeing across this sheet right now is you're actually seeing the faces of a quote-unquote die that are representing these numbers in this column. I'm going to hide those again because we don't really need those. What we need is to look at these. So every time I press F9, as I said, I get new die rolls. Now, sometimes you may have noticed that look at that. Oh my goodness, I'm so glad we saw that. This is case in point when you're talking about randomness. I'm so very, very happy that this just happened. Just for those keeping track, we've rolled 11 dice and and gotten 9 ones out of 11 rolls. Take a look at it over here. You can see it. It's right there. It happens, my friends. This can happen. And this is what breaks people's brains when something like this happens. They see 9 ones out of 11 rolls of a die, and they assume that something's wrong with the dice. I'm now going to press the F9 button. And we're going to get new dice. There you go. And nothing there probably jumps out and grabs you like the last screen that we just saw when we had 9 ones out of 11. However, that 9 ones happening out of 11 was just normal happenstance within the realm of what is randomly possible. Okay, that was fun. I'm really, really glad we got to see that. What I'd like to look at now is a little more organized way of keeping track of the same data. Same data, but I'm going to click over to this tab. And what this tab does is it simply tells us how many of each of these results are we seeing up here. So let's slowly look at this. Pips is the fun, proper name for the dots on a die. So 1 through 6. This column here, how many, is simply counting how many of these 11 dice up here have that many pips on them. So right now, current, there is 1 die with 1 pip. There it is right there. Right there, that right there. There are 2 dice with 2 pips. They're right there next to each other. That's nice. There are 2 dice with 3. Oh, there they are next to each other over here. There are 4 dice with 4. 1, 2, 3, 4. There's 1 die with 5. Must be right there. And there's 1 die with 6 right there. 9 again. Now we've got a slightly different kind of distribution, right? We've got a little bit of distribution. We got 3 1s, 4 2s, 2 3s. We got no 4s and no 5s. Interesting. No 4s and no 5s. Let's do it again. Okay, now we got no 3s and no 6s. Now we've got a little bit of each. Now we're missing 5s and we have a lot of 2s. Now we've got a nice spread of each. Nice spread of each. Now we're missing 3s. Now we're missing 2s. And what's interesting about these results is from a random point of view, nothing's amiss. But from a human point of view, something might be amiss. For example, this distribution right here of 11. If this happened to you right off the bat, kind of like my 11 dice falling in front of you right off the bat, it might throw you for a loop because there are no 1s, no 3s, and no 4s. In other words, we have what you would call gaps. Sometimes we end up with a distribution of, I'm trying to get one right now, it's getting hard, that might tell you something about it. I'm trying to get one where there's no zeros. There we go. Sometimes we get a distribution of 11 dice where you've got at least one of each. But as you just saw, very often there are zeros popping in there. And this situation right here is similar to what we saw on my 11 die rolls. My 11 die rolls, if I remember correctly, had no sixes. I have them written down over here. No sixes and no fours. Now, what's interesting in this one is there's no ones and no fives, but there's no rule for randomness. Or is there? So what I decided to do, and in the next video we're going to look at it, is keep track of how often this happens. Let's take a look.